All right, so let me switch to my pad. All right, so y'all should be seeing a blank paper at the moment. And that's what you'll be able to follow me as I write notes in this section. So I just want to review you before we actually do the 4B topic for MR. I want to refresh you on changing percents into decimals, because you're going to have to do that all through these problems, okay? So let's refresh on changing percents to decimal. So if I had 78%, and we need this to be a decimal when we put it into the mathematical formula, basically we're going to divide by 100. And what dividing by 100 does to the 78%, since there's no decimal shown, it would automatically be behind that 8. And I want to turn it into percent. I automatically move that decimal left 2 units so that I get a 0.78, and then we drop the percent from it. So you always got to move it left twice to turn any number into a decimal. So another example would be, y'all, what about something like 5%? If I want to turn 5% into a decimal, I've got to do the same thing. I've got to move that decimal left 2 units. So at the moment, that decimal is behind my 5. So I'm going to move it left 2 units. And what I got to do is add a 0 as a placeholder, and then add that decimal in front of that 0 so that I get a 0.05%. I mean, 0.05 as my decimal. Okay. I could have something like 28.4%. I still need to turn this into a decimal. And y'all, we would still do the same thing. Move the decimal left 2 units so that you get a 0.284. So a lot of times this messes people up because they see 3 numbers and they always think it should be right before the last 2 numbers. But that's not true if that decimal is not behind the 4. Since the decimal is behind the 8, we just had to move it left twice and it put it in front of the 2, okay? So y'all, that's the main thing we got to be able to do in this section, okay? So we're going to start our MR4B section. And the first formula we're going to play with is what we call simple interest. All right, so let me let one in real quick. All right, y'all, so simple interest is just interest that they charge me once a year, okay? So if I had 5% interest, they would charge me that once a year, and that would add to my total, okay? So it's just charged once a year. So the formula we got for that is A equals P times parentheses. Now, I'll tell you what all the letters mean in just a second. Inside the parentheses, we have 1 plus APR times Y. So my APR went up a little high, y'all. That should be right in line with it. So P times parentheses 1 plus APR times Y. So let me show you what these mean. A is the final amount. that you're going to pay with this interest. P is your principal. And y'all remember, principal is your starting amount. All right, then we got parentheses. The one is always there. APR. APR is your percent rate. Now remember, when I use the formula, this percentage rate has to be in decimal form. Okay, we cannot put the percent symbol into our formula. All right, then Y. Y is going to be the number of years. Okay, so this is the formula they came up with. So let me let one in. So they're going to give me an APR. I turn that into a decimal, multiply by the years. Once I get that answer, I add 1. That'll have my parentheses completed. Then I'll take that answer and I multiply by P, which is my principal. This gives me a total amount of what happens when the principal has that percentage of APR applied to it. All right, so I'm going to work a formula, some of these formulas in just a second. So let me give you number 2 here. So I'm going to give you a simple interest formula and then a compound interest formula. Then we'll work examples doing that. Then I'll come back and give you the annual percentage yield formula and the other one I talked about, okay? This one is for compound interest. All right, so basically compound interest is interest that they might apply more than once a year. So if you made an investment of $1,000, simple interest would give you that interest once during the year. Compound interest could do it annually, which is once a year, semi-annually, which is twice a year. What else we got? Quarterly, which would be 4 times a year. They could do it monthly, which is what, 12 times a year, or even daily compounding, which would be 365 times, okay? So the formula is very similar, but a little different. So here we go. A, which is my amount, is going to equal P, which is our principal, times parentheses, 1 plus the APR divided by N. And then all this is raised to the exponent N times Y. So the new letter that we need to know is, what is the N? Well, y'all, N is the number of compounds per year. So number of compounds per year. So what it does is it takes that percentage rate, divides it by ever how many times it's getting compounded, adds it to the 1, and then they came up in the formula that you multiply those compounds by the number of years that the loan is going to be for. So we're going to do some of the examples on the simple interest and the compound interest now. So let me get them ready. All right, so my first example, you invest $3,000. All right, $3,000 is invested in an account that pays simple interest of 6%. So simple interest of 6% for 30 years. So we want to know how much money will we have after 30 years if we invest $3,000 at a simple interest of 6%. So what that means is once a year, they'll give me 6% of what my money's worth, add it to it, and then the next year they'll do the same thing for 30 years. All right, so I'm going to use my simple interest formula, which is A equals P times parentheses 1 plus the APR times the years, which is the Y. So 3,000 is my P because that's my starting amount or my principal. So 3,000 is my P. 30 years, well, that's going to be my Y because that's my years. So right here's my APR, but y'all remember, I told y'all we had to turn that 6% into a decimal. So there we go, 6%, the decimal's behind the 6. So we need to move that left 2 units, which means I'm going to have to add a 0, and that's going to be a 0.06. 0.06 is my APR now, okay? So now that we got everything we need, we're going to go plug it into this formula, and we're going to follow order of operations. So here we go. P is 3,000 times 1 plus my APR, which is 0.06, times Y, which is 30. Okay, so at that point, if you wanted to, you could punch it straight onto that calculator. Okay, but by hand, let me show you what you're doing to this. By hand, we follow PEMDAS for order of operations. So I got to work inside parentheses first, then I do exponents, then I would multiply or divide, then I would add or subtract. So I got parentheses here. Inside the parentheses, I still got to follow the order of operations, which means you got to multiply first. So you would bring down your 3,000 times parentheses 1 plus, so 30 times 0.06 would give me 1.8. And y'all, you can multiply that by hand if you want. All right, now I still got the parentheses, so I need to add 1 plus the 1.8. So the 3,000 comes down. But now, since that's the last thing I got to do in the parentheses, I can remove my parentheses. And 1 plus 1.8 is going to be 2.8. All right, final step. Since the parentheses are gone, now I can multiply my 3,000 times 2.8. So 3,000 times 2.8. And it looks like my money is almost going to triple at 8,400. So simple interest, since it only gives you the interest once a year, is not the best thing at making money, but it's a stable way to make money, okay? But notice after 30 years, you made about, what, $5,400, okay? So y'all got any questions on that problem? If not, I'm going to do another one just like it. So this time we're going to invest $3,900 in an account with an annual interest of 4.9%, and we're going to do that for 10 years. Okay, so an annual interest is the same pretty much as a simple interest. All right, y'all, so let's see. The only thing we need to do is convert that 4.9% into a decimal. So the decimals after the 4, I'm going to move it left twice, which means once again, I got to add a 0 and make that a 0.049. That is now my APR. And I'll tell you where I kill people on this. They get rid of the percent and they leave that 4.9 there. And if you leave that a 4.9, it's not going to work out, okay? All right, so watch this. We're going to plug it in. We know the formula. A equals P, which is $3,900, times parentheses 1 plus my APR, which is 0.049, times my years, which is 10. Okay, now y'all, I'm going to show you on that calculator. Y'all got them TI-84s. Let me show you. This thing will go quick on this calculator. You would put it in just like it looks. You would put in your 3,000. You got parentheses above the 8 and the 9, so hit your parentheses. Then it's 1 plus 0.049 times 10, close those parentheses. So it's just like we got. We're going to hit enter, and we get oh, I can't see what I got there. Oh, I need to do that for 3,900. My bad. Let me start over. I see what y'all are looking at. I needed $3,900 there, so 3,900 times parentheses 1 plus 0.049 times 10. All right, so yeah, I was probably wondering where I got that 3,000 from myself. So this problem had $3,900, so now we're good. We hit enter, we get $5,811. So 4.9% simple interest. You're just not going to make a whole lot of money, but you're making money, okay? All right, so I got more coming in. Let's get them in. All right, y'all. So y'all want one more of these, or are y'all ready to move on to that compound? All right, so I guess y'all are ready to move on to the compound interest, so here we go. All right, y'all, $2,000 is invested at an annual percentage rate of 9% for 6 years. If interest is compounded semi-annually, so semi-annually, what is the amount after these 6 years? All right, so I'm gonna move that down just a little bit so we can get this problem on here. So semi-annually, they're compounding this one. So we need to figure out what semi-annually means, and that means 2. So that means that our N in this formula will be 2. We still need to change this decimal, this percent into a decimal. So the decimal's after the 9, we need to move it left twice. So that's going to give me a 0.09 for my APR. 6 will be my Y for my years, and then 2,000 will be my principal or my starting amount. All right, y'all, so this formula was A equals P times parentheses. So they both start out the same. They both got a 1 here, plus, now here's the difference. On this formula, we take the APR and divide by N, which is the number of compounds, and then we raise that to the N times Y. So let me tell you how you do this problem. You work inside the parentheses first. You would divide whatever your APR is by N. You would then take that answer, add to the 1. Once you got this answer, you would figure out this exponent. You would multiply that N times Y. Then raise this answer to that exponent. That'll give you a number. And then finally, this gets multiplied by the P. Okay? All right, that sounds sort of wild, but watch. Here we go. We're going to have A equals P, which is 2,000, times parenthesis 1 plus APR, which is 0.09, divided by N, which was 2. All right, you close in parentheses, and then out here you had N times Y, which will be 2 times Y, which was 6. Okay, so like I did this one up here by hand, I'm going to show you how I would do this one by hand, okay? So I bring down that 2,000 times, that 2,000 is going to be the last thing you do is multiply that 2,000, okay? We got to do the parentheses first. So this would be 1 plus whatever 0.09 divided by 2 gives me. So that's a 0.045. And now, since this exponent is right out here, we can go on and multiply 2 times 6, make that a 12. All right, so I still got to work inside here, so I would bring that 2,000 down, times 1 plus 0.045 is 1.045, and that's all still got an exponent, it's 12. So now, before I can multiply, I gotta turn this number and raise it to that exponent. So I would bring down to 2,000 times, let's see what, 1.045. To do exponents, you hit this little arrow key right under the clear, and it kicks it up to do exponents, and then you put in your 12. Now let's see what that gave me. So I'm going to round that a little bit to a 1.69588. You still want to keep a lot of the digits. Now, but since this is on the calculator, I'm going to multiply now by the 2,000, so times that 2,000, my last step, and I get $3,391, and we're going to round that to the nearest cent. So that's what, 70, the 6 has a 2 after it, so the 6 is going to stay a 6. So on that problem, the trick was getting that APR, 0.09, and then remembering that semi-annually means it's going to happen twice, okay? All right, so we're going to do definitely some more of these compound interest, okay? All right, y'all, next example. What if I'm investing, so let me come up a little, $12,000 for 8 years APR of 4%, and quarterly compounding. All right, so we know what we need for our formula. We need our P, which is going to be that 12,000. We need a Y, which will be the 8 years. They told me this was APR, but I need to turn 4% into a decimal, so I'm going to move my decimal left 2 units, add a 0, so that's going to be 0.04. And then N is the compounds. This time they gave me what? Quarterly. So quarterly means it would happen 4 times in a year. All right, y'all, so here we go. We know our formula. A equals P, which is 12,000, times my parentheses, which is 1 plus my APR 0.04, divided by N, which is 4, all raised to the exponent N, which is 4, times Y, which is 8. And I'll tell you why they do this part right here, because the number of compounds times the number of years gives you a total of 32 compounds that's going to happen to this interest rate, okay? They're doing this 32 times. That's how you make money on these, okay? All right, let's see. So since we did the last one by hand, I'm going to show you how you would punch this one on that calculator. So you would punch in 12,000 times your parentheses, 1 plus 0.04 divided by 4. Then you close those parentheses. Now we got to do the exponent, so you hit the caret key. It kicks the cursor up, and you do 4 times 8. But really, at that point, couldn't you have just put a 32 there if you wanted to? Now, y'all look on the screen. On the older calculators, after you do the exponent bar like that, older calculators, they put parentheses. You got to do the 4 times 8 in close parentheses. Newer 84s do not do this. They do like mine's doing. But the older ones use the caret with parentheses, and you got to close them after you multiply, okay? All right, so I got that in. So what I would do now is hit enter, and we're going to round to the nearest cents. So I get 16,000. Let's see, that's going to be 499 point. So 28. So since there's an 8 behind the 8 in front becomes a 9. All right, so are y'all getting used to this one now? Hopefully it's making more sense. I'll definitely do a few more of these compound interest ones for you. All right, on this one, $25,000. At an APR of 6.2%, quarterly compounding, for 33 years. So that is definitely a long investment, okay? But I'm going to see what's going to happen to my $25,000 that I'm investing at 6.2% with quarterly compounding. So here's my P, my starting amount. APR, I'm going to have to move this decimal left twice. So I'm going to add a 0. So that's going to be a 0.062. Quarterly compounding, what's that mean? N equals 4 again. And then 33 years is my Y. All right, so here we go. We got A equals P, which is 25,000, times parentheses 1 plus APR 0.062 divided by N, which is 4, all raised to the exponent 4 times 33. But notice this, in 33 years, that's going to be quite a few compoundings adding to this money, okay? All right, so here we go. We would punch in 25,000 times parenthesis 1 plus 0.062 divided by 4, close our parentheses, and then we do our exponent with the caret key, and that's 4 times 33. All right, y'all, so we're about to see what happens to $25,000 invested at that percentage rate, compounded quarterly for 33 years. Y'all ready? Here we go. Woo, y'all look at that. That is, oh my God, that's like $190,000, 410. And rounding to the nearest cent looks like what, a 31, because that's a 4 after it. So if you could afford to invest $25,000 for that long, you've got almost $200,000, okay? So you made almost $165,000 on that, maybe. So that ain't too bad. All righty, so I'm about to give you more formulas. All right, so the next thing we're going to look at is what we call the annual percentage yield. Okay, so we're going to call that the APY. But this is the actual amount your account increases during the year. See, if you're at a 2.5% loan interest rate, by the end of the year, if it's compounded a few times, your annual percentage yield might come out a little bit higher due to the amounts being compounded, okay? So you actually do make more money than the percent you're getting if it's compounded, okay? So this annual percentage yield, the way we find it is that the APY equals the absolute change over the principal. And y'all, when you use this formula and you just want to compare how interest rates from different banks might actually give you money and how they affect you, when I do this, you can choose any amount for your principal. So I'm going to choose any amount I want. Now I'll tell you the amount I usually choose. So I usually choose $1,000 because that's easy to work with, and I can use that every time on this formula. Okay, so in my formula, my principal will always be 1,000 because we just want to see what happens to the interest rate. That's all we're worried about. Now to find this absolute change, what you're going to do for absolute change, you're going to find the amount the account grew in the year minus the amount you started with. So let me tell you what I mean by that. So say I did invest this $1,000 and I invested it at say 5%. Okay. And it did all of its compoundings. And after the end of the year, I ended up with $1,054. So the absolute change would be that 1,054 minus the 1,000 I started with. It would be the amount it actually grew, which would be the $54, okay? And I'll show you those when we're working these problems also. Okay, y'all, so let me go do a few problems doing the annual percentage yield. And now really, when I'm finding that absolute change, I'm going to still be using my compound interest formula, okay, just to let you know. So we're going to find the annual percentage yield with a bank that offers 4.2% compounded daily. So we're going to find the annual percentage yield on a bank that offers 4.2% interest compounded daily. Now, I will need to do some of these figures when I'm actually finding what it grew, okay? So I'm going to let my P equal 1,000. That's what I'm choosing. And Y for these problems is always going to be 1 year, okay? So here we go. 4.2%, we need to turn that into a decimal, moving it left twice. So that's going to be a 0.042 for my APR. Compounded daily means N is going to equal 365. All right, y'all, here we go. We got to find what the account grew, so we got to find our A. We're assuming we're putting in $1,000 times parenthesis 1 plus my APR, which is 0.042, divided by my N, which is 365, all raised to the N, which is 365, times my Y, which is 1. This will give me how much money I have after the end of that first year. So I'm going to punch that on my calculator. I got 1,000 times parenthesis 1 plus 0.042 divided by 365, close parentheses, caret for the exponent, and then 365 times 1 is basically 365. So let's see what happened to our $1,000 after 1 year at an interest rate of 0.042. So I hit enter. I get $1,042, and y'all, let's call that 89 cents. So that's how much my account made in the first year. Now remember, to find the absolute change, because the absolute change is going to be the top part of that formula when I find that APY. My absolute change is this $1,042.89 minus the starting amount, or my P, which was 1,000. So we figured that out, and that's going to give me what? $42.89. That's how much my account changed. It went from 1,000 to 1,042.89. So remember, my APY formula was equal to the absolute change on top, which was 42.89, divided by my principal, and that's the amount I made up, my 1,000, All right, so let's see what 42.89 divided by 1,000 is going to give me. So y'all, I get a 0.04289. Now they want this written in percent, 2 decimal places after that decimal. So to go from decimal to percent, you move the decimal right 2 units. So that's going to give me a 4 point, and then 2 decimal places will be where the 8 is at. Since there's a 9 behind the 8 turns into a 9, so that I get 4.29, and then we add our percent. So look, the actual yield was 4.29%, but the bank signed me up at 4.2%. So I actually almost made 4.3% on my money due to all those compoundings, okay? Well, y'all learning about some money tonight, ain't you? So about 5 of you are, for sure. All right, I'm going to do another one of those because these are fun formulas, right? Oh, I don't see no thumbs up, but they're fun. All right, same thing. We're going to find APY. Okay, this bank is going to have APR is 3.97%. Compounded monthly. So this one is compounded monthly. So monthly means my end this time would be 12. Okay? And then I got to find this decimal over here by moving that left 2 units. So that's going to be a 0.0397 for my APR. Once again, I got to get a P. So I'm going to let P equal 1,000 again. So I'm investing $1,000 again, and Y is always 1 on these problems, okay? So let's see if our annual percentage yield is better than that 3.97. All right, so remember, the first thing we got to do is see what happens to our $1,000 for 1 year at this percent. So we got A equals P, which I said I was going to let be 1,000, times parenthesis 1 plus APR 0.0397 divided by N, which is 12, all raised to the N, which is 12, times Y, which is 1. All right, so I'm going to push that in. 1,000 times parenthesis 1 plus 0.0397 divided by 12, close parentheses, and then carry it up for the exponent. And y'all, 12 times 1 is just 12. So I'm going to hit enter, and that gave me, what's that look like? 1,040 point, no, I'm going to call that 43. So once again, that was my amount I made for the year. I'm going to subtract my 1,000 I started with to get my absolute change of $40.43. All right, so last step, find that APY. APY equals my $40.43 divided by my imaginary 1,000. So let's see, 40.43 divided by 1,000. I'm getting a 0.04043. All right, so we got to move this decimal twice. So it's going to be behind the 4. So that's 4 point. Remember, I'm rounding 2 decimal places. So that's where the 4 is. Since that's a 3, that's going to stay a 0.4. And then I add my percent. Now, I think on MATLAB, they give you that percent. So you're just going to put in that 4.04 and be done with that. So let me tell you, that's fun, right? That's pretty lengthy formula. And I finally got one more formula for you. So let me get this last formula written down. And this formula is for finding the principal. So this would be my 4th formula. And this is finding principal. So let me tell you what this means. So say in 10 years you want to have $50,000 to put down on a house. Okay? This formula will tell me how much money you got to invest at a certain interest rate being compounded for ever how many years you want to save it. This looks for that starting amount, okay? Because remember, P in our formula before was our starting amount. So now we're going to use the end amount we want to find what we got to start with. So this formula is P equals the A, which is the amount you want to end up with, divided by 1 plus APR divided by N, all raised to the N times Y. So basically what they did, this part was being multiplied by the P equal to the A. Well, to get the P, you divide the A by all this. And this is all still the same thing. A is my amount I want. APR is going to be the percentage rate in decimal form. N is going to be the number of compoundings, and we use that twice. And then Y will be the years. So we're going to need to do a couple of those examples. So y'all let me find my page. All righty, so I'm going to do this one right here. I'm going to have $50,000 in 6 years. So I want, so 50,000 wanted in 6 years. For a down payment on a house, I'm going to get an account with monthly compounding. So monthly compounding, and the APR is 4%. So this will tell me what I need to invest now at this percentage rate for 6 years to come up with $50,000. Okay? So remember, APR has to be a decimal, so I move that left twice. So that's going to be a 0.04. Monthly compounding means N is going to equal 12. And then here's my Y. And remember, this time 50,000 is my A. That's my ending amount I want. So to find the starting amount, we're going to take the 50,000 divided by 1 plus my APR, which is 0.04, divided by N, which is 12, all raised to the exponent, N, which is 12, times Y, which is 6. So to do this problem, you would work inside the parentheses, divide first, then add the 1. Then you would raise that to, what's 12 times 6? 72. Raise that to the 72nd power. Then the last step is to take this 50,000 and divide by everything you had on the bottom. Okay? So on the calculator, let's do this. I take the 50,000 on top. I divide by parentheses 1 plus 0.04 divided by 12. Close those parentheses, and then our exponent is 12 times 6. So let's see what we got to start with to have $50,000. So this is telling me to have $50,000 in 6 years, I need to start with $39,347 and what's that, a 09? So in 6 years, I can make $10,000 at that interest rate pretty much because I start with 39,000. So yeah, there you go, right? You have to start with $39,347.09 to have $50,000 available in those 6 years, okay? All right, I'm gonna do my last one. This is about a college fund. So how much must be deposited today in order to have $105,000 in 12 years for college fund? Now this bank has quarterly compounding. So quarterly compounding and an APR is equal to 7.66%. Yo, if you notice, I got everything I need again. I know this is my A, that's my ending amount I want. I know 12 is my Y. N, quarterly, means 4 times a year. And I'm going to have a big decimal here, but I got to move it left twice. So I get 0.0766. All right, once again, we're going to plug it right into our formula. P equals my A, which was 105,000, divided by parentheses 1 plus your APR, 0.0766, divided by N, which is 4, all raised to the 4 times N. That's my N. So my Y was what, 12 up here? All righty, so after I punch that in, we'll see how much we got to invest so that in 12 years, I'll have $105,000 at a quarterly compounding of 7.66%. All right, so here we go, 105,000. That's like 105,000, right? Divided by parentheses 1 plus 0.0766 divided by 4, close those parentheses, and then carry it up for that exponent. And y'all, what was that, 4 times 12? Or you could have put 48 there. So either way, hit enter, and I would have to invest $42,243.50. Ooh, that 1 has a 7, so that 1 becomes a 2. So if you want $105,000 in 12 years, you got to start with 42,000. I guess you got to have money to make money, right? All right, everybody, that was my MR lesson for 4B. So my next class, we will be discussing stuff like installment loans and credit cards and some of that kind of debt, okay? So let me stop this share and go back to our main screen. So does anybody have questions? I see a chat. Let me see what that says. Okay, what kind of one more? Someone said one more. Caught me, what kind? Doing the same thing I just did? Oh, you got it now? Okay, so since y'all got it, then we will end this message and I will send this video out to y'all. So if you came in late, I did a few formulas in the beginning doing simple interest. Then we got into the compound interest pretty heavy. So it'll probably take me about an hour, hour and a half to get this all the way uploaded on YouTube, but it will be there tonight, okay? So we'll stop this recording.